So the next derivative rule I want to look at is how do you take a derivative when you've got a quotient of two functions? So f divided by g. And again, I'm going to just state the rule here, and then we'll prove it in the next video. We'll state it and give a few examples. So here we go. How do I do this? What's the derivative? Well, the quotient rule is probably the most complicated of the basic rules that we look at here. And as we do more, I'm hedging my thoughts here. As we do more, we'll understand why they work the way they do. Actually, the quotient rule and the product rule are very closely related, although they don't immediately look at, I guess. But once we have this thing called the chain rule, we'll be able to do them and show how they really are the same. But for now, so g's on the bottom, we're going to put it on the bottom again, but we're going to square it. So g squared on the bottom, write it on the top. Whoops, too many parentheses there. G of x times the derivative of the top. So I've got the bottom times the derivative of the top minus the top times the derivative of the bottom. Okay. Times the derivative of the bottom. There we go. The numerator looks a lot like the product rule, right? The product rule was, the first times derivative of the second plus the second times derivative of the first. And with the plus sign in there, it really didn't matter what order you did it in. This has a minus sign, however, and the order does matter because 3 minus 5 is not the same as 5 minus 3, right? That is the order that you subtract things in makes a difference. So one of the reasons why I wrote it the way I do is that I have to get the top started in the right order. And what I do is I get it started by saying, hey, whatever was on the bottom is still on the bottom. Square it, write that same thing down again. So I get the G, right? So bottom times derivative of the top minus top times derivative of the bottom. That's the numerator, and then you divide it by whatever the bottom was squared. Okay. For instance, how about if I've got y equals x cubed over 4x plus 7? Y prime is the 4x plus 7 is in the denominator, squared. There's a 4x plus 7 right here. That's going to be multiplied by the derivative of the top, so the derivative of x cubed minus the top times the derivative of the bottom. And I'm writing more than I normally would write just because this is, the first example, and don't want to do too much at once. Just take it step by step. Later on, I'll do these derivatives on the fly, but for now, let's just focus on the fact that we did the quotient rule. Bottom squared, bottom times the derivative of the top, minus top times the derivative of the bottom. Okay. Now, there's a couple of very common mistakes people make here. One is to not put parentheses around this, in which case then this doesn't necessarily get distributed to both of them. Okay. The other is it's really, 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 really common for people now to cancel out a 4x plus 7 here in one of those, right? And the problem is it doesn't cancel because this 4x plus 7 is not a factor of the top. The top is got a big old minus sign in the middle, so it's not completely factored, and you can't cancel until it is factored. So please don't cancel that out. So here we go. We've got the quotient rule done, and now the quotient rule gave us two other derivatives that we have to handle. We focus just on each one of them. So there's a 4x plus 7 here, right? Now I need the derivative of x cubed. Well, that's a power rule. That's 3x squared, right? Then there's a minus x cubed here. And now I need the derivative of 4x plus 7. Well, that's a sum, so I need the derivative of 4x, which is 4. And I need the derivative of 7, which is 0, right? And then that's still all divided by 4x plus 7 squared, right? Can we cancel the 4x plus 7 squared out now? No, we can't, because there's still that minus sign in between. Right? So anyway, at this stage, we're done taking the derivative. Anything we do now is sort of cosmetic. It's algebra, but I do see some things that are going to cancel, to combine at least. So I'm gonna do the algebra here. I've got 12x cubed plus 21x squared, and then there's a minus 4x cubed there, and I still got a 4x plus 7 cubed on the bottom, and so I see some cubes get together there. So I got a 12x cubed minus 4x cubed is 8x cubed plus 21x squared, all divided by the 4x plus 7 cubed. And there's no way that I would multiply that out unless I really had some reason that I knew I was going to do something with it later. Anyway, I'll just leave it like this at this point. Okay. The quotient rule. Bottom squared on the bottom. The top looks like the original denominator times the derivative of the top minus the top times the derivative of the bottom. Okay. So there's your quotient rule. Let's do one more example here. How about something like y equals x to the fourth plus 3x cubed minus 7x plus 2 all divided by x squared. I'm going to actually do this two ways. First, I recognize that, hey, this is a quotient. If you gave me a value of x and I had to plug it in and figure out what y was, I'd, raise it to the fourth power, I'd cube it, I'd multiply by 3, I'd multiply by 7, I'd add 2, and I had all this stuff up in the numerator. I'd figure out what the denominator is. And then the last thing I do is whatever the numerator is divided by the denominator to get y. Right? This is a quotient, and so I have to use the quotient rule to take the derivative. Okay. So y prime is whatever was on the bottom, it's still there, squared. And start with the bottom here. And now I need the derivative of the top. So I need times the derivative of all this stuff. X to the fourth plus 3x cubed minus 7x plus 2. At some point I'll take this derivative on the fly, but for now I think it's just as well to write out, step by step. So that was the bottom times the derivative of the top minus the top, so in parentheses, plus 3x cubed minus 7x plus 2 times the derivative of the bottom. We have just enough room and make sure this fraction bar is long enough. So anyway, boy, can I cancel all this x squared here? No, of course I can't. There's a minus sign, right? Okay, so here we go. So I've got x squared times, what's the derivative of this whole thing? Well, it's polynomial. I can just do the derivative of each piece and add them up. So I've got 4x cubed plus 9x squared minus 7 plus 0, and then minus this polynomial, x to the fourth plus 3x cubed minus 7x plus 2 times the derivative of x squared, and that is 2x. And that's all over x to the fourth now. Can you cancel out this x squared with? No, of course I can't because there's a minus sign there, right? Okay. Now, at this point, we've taken the derivative. Anything else we might want to do is just algebra. Actually, but I do want to do it. I do want to do it. How much time? Lots of time. So I've got 4x to the fifth. I'm just distributing now. Plus 9x to the fourth minus 7x squared. I'll distribute the negative 2x in here. So negative 2x to the fifth minus 6x to the fourth. The negative negative becomes plus 14x squared. And then a minus 4x. This is all over x to the 4. And then I'm hoping that I've got some things that kind of go together here. Yeah, I've got a 4x to the fifth and a minus 2x to the fifth. So that would be 2x to the fifth. I've got a 9x to the fourth and a minus 6x to the fourth. So that would be 3x to the fourth. And then I've got a minus 7x squared and a plus 14x squared for a grand total of plus 7x squared. And I've got a minus 4x over there. And the whole thing is divided by x to the 4. One last thing I can do is I can factor an x out of everything and then cancel it with the bottom. So I can just cut these all down by 1. So I've got 2x to the 4 plus 3x cubed plus 7x minus 4 over x cubed. So I canceled out one of the x's with all of that. So there's one way of taking that derivative. And I'm going to do it one more time. So I'm going to write this down again. Actually, I think what I can do is I can circle it. I can say copy, and then down here I'm going to say paste. Good, there we go. All right, so let's do this again. Let's find the derivative. But what I'm going to do this time is I'm going to do some algebra first and rewrite the function. Right? You always have this option when you're doing derivatives. You can either just take the function as it is and apply whatever derivative rule is appropriate, or you can rewrite your function to look a little different and maybe use different derivative rules. So I'm going to rewrite this as x to the 4 over x squared. I'm distributing the 1 over x squared here into this. So plus 3x cubed over x squared minus 7x over x squared plus 2 over x squared. And then there's stuff that cancels here, because right, this is x squared plus 3 times x minus 7x to the minus 1 plus 2x to the minus 2, and now that's still y. Now I can take the derivative as using the polynomial stuff, right? So I've got a sum, and also just take the derivative of each piece and then add them up. So this is 2x plus 3. This one is plus 7x to the minus 2, and this is minus 4x to the minus 3. Is that the same answer that I got before? Well, let's see. There's the 2x to the 4th over x cubed. That would be this. There's a 3x cubed over x cubed. That's the 3. There's 7x over x cubed. That's this one. And the negative 4 over x cubed. Yes, they are the same. Okay. So anyway, there's almost always options that you'll have as you do these things. Rewrite your function to use one set of derivative rules, or rewrite it a different way to use another set of derivative rules. Okay. As long as you're doing legal algebra, you're not doing anything wrong. You may not be doing it the simplest way, but you're not doing anything wrong. There's the quotient rule.